Hi, in this third video of Unit 3, we will deal with selected reactions of boron, aluminium, and group 14 elements. Let's start with the hydrometallation reaction of boranes to unsaturated molecules, that is, hydroboration. Hydroboration is by far the most widely used method for making boron-carbon bonds and has developed into one of the most versatile methods in organic synthesis. Hydroboration is regioselective. The electropositive boron is going to be attached to the carbon atom bearing the larger number of hydrogen atoms following the anti-Markovnikov rule, and also stereoselective with a cis addition. Although it is reversible, the equilibrium normally lies in favor of product rather than reactants in ether solvents at room temperature. However, on heating above around 100 degrees, organoboranes with a beta-carbon-hydrogen bond eliminate alkene, that is, the reverse reaction takes place. We'll go back to this beta elimination reaction in class. Alkyl aluminium compounds are produced on a very large scale in industry. This is remarkable considering their extreme reactivity towards oxidation and hydrolysis, which makes handling dangerous. Organoaluminium halides and alkoxides are not so reactive, which could be related with their tendency to form dimers and oligomers. The extraordinary reactivity of organoaluminium compounds has led to a multitude of synthetic applications. Just very briefly, let's highlight some of them. For example, carboalumination, which is the insertion reaction of alkenes and alkynes in aluminium-carbon bonds. As in the case of hydroboration, it is the products of subsequent reactions of the initial organoaluminium adducts that are of practical interest. On the other hand, careful hydrolysis of trimethylaluminium affords methylalumoxane, known as MAO, which is a highly reactive co-catalyst with group 4 metallosenyl halides in olefin polymerization reactions. And finally, let's also point out that aluminium organelles are strong Lewis acids, stronger than organoboron compounds, and that's why in group 13 only the aluminium organelles form dimers. As they are Lewis acids, reaction with tertiary amines usually provides adducts formation. But in the case of secondary and primary amines, subsequent reaction occurs. The Lewis acid-base interaction results in an increase in the carbanion character of the methyl group, as well as in an increase in nitrogen-hydrogen acidity. Thus, the elimination of methane is facilitated. Finally, closely related to carboalumination, let's remember hydroalumination, a metallation reaction which consists in the addition of aluminium hydrogen to unsaturated bonds, or, in other words, the insertion of an unsaturated molecule into an aluminium-hydrogen bond. Hydroaluminations are highly stereoselective with a cis addition. However, the degree of regioselectivity, anti-Markovnikov, depends on the olefin in this case. Regarding the reactivity of organometallics of group 14, let's point out some general facts. In nearly all the organic derivatives, silicon, germanium, tin, and lead are tetravalent. Their thermal stability decreases down the group in parallel with the trend in metal-carbon bond energies. Bonds between carbon and group 14 elements are usually stable to hydrolysis under neutral conditions, influenced by the low polarity of that bond. Tetraalkyls behave as saturated compounds, showing little tendency to increase their coordination number above 4 unless they are attached to electronegative atoms or groups. They do not tend to associate by alkyl bridges and are kinetically stable to oxygen. Tetramethylsilane is so chemically inert that is chosen as an internal standard for NMR spectroscopy. Organic derivatives of group 14 find applications in diverse areas. Especially important are the silicon polymers, organotin compounds as stabilizers for plastics and as biocides, and during last century, organolead as anti-knock agents for petrol.